So right here I'm talking about Boyle's law. So Boyle's law has the formula P1V1 equals P2V2. 1 is initial, 2 is final. And here does not have temperature, meaning temperature stay the same. And how this law works is pressure and volume is inversely proportional, meaning when pressure increase, volume decrease, or when pressure decrease, volume increase. So they are inversely proportional. And if we need to find the changes of pressure, we can have this formula P1 minus P2. And then when we need to find the changes in volume, we can have V1 minus V2, okay, absolute value. And so first, let's look up the question. Standard temperature and pressure. Standard temperature and pressure is STP. So every time when you see standard temperature and pressure is always 1.00 atm, and temperature is always 273 Kelvin. Okay, so we first will want to list out the information we can find from the question. Now sometimes the initial information is not necessary at the beginning of the question. At the beginning, I can give you final situation of the question, so you have to be careful, read the question. So here 1.00 liter is V1, V2 is 473 ml, but they're not to have the same unit, so we have to use 1 liter equals 1000 ml to change that from ml to L, or you can change the L to ml. Either way is fine, as long as finally these two volumes have the same unit. And the pressure is 1.00 atm because it's standard pressure. And then my temperature T1 should be 273 K. And then what is the new pressure? The new pressure, I don't know, so question mark atm. And they say temperature stay the same, so my T2 will be also 273. This is 1 point. And then another thing is we want to determine what law is that, because we have 7 laws. So we want to write, okay, my volume is changed from 1 to 473, my volume change. My pressure also get changed because whenever they ask you like question mark, that means the pressure is no longer the original pressure, is a new one. So as long as you see question mark, it's also changed. So my volume and pressure change. My temperature stay the same, 273. Now sometimes you don't need to know the temperature, the number. As long as they say stay the same, then it's fine. Because in the Boyle's law, temperature is not there. Temperature stays constant. That means temperature will be cancelled. So it doesn't matter where you do not see the temperature number, as long as the question somewhere say that it stay the same. So because of these two conditions, we say the Boyle's law. Then here we want to write down the original formula P1V1 equals P2V2. And then we want to look for P2. So how can I isolate the P2? Is I'm going to divide both sides by V2. So I rewrite the formula and then I divide both sides by V2. So then V2 here cancel. All right, rearrangement of the formula. And then finally, I will get the additive formula, P2 equals P1V1 over V2. Then I substitute my numbers with the unit cancellation. And then finally, I get my calculated answer. And then 2 decimal place answer with the unit. Okay, so let's look at the second question. In a thermonuclear device, the initial temperature is 260 K. So I can write T1 is 260 K. The pressure of 0.05 liter of a gas within the bomb casing reaches 4.0 times 10 to the power 6 atm. So here 0.050 is not pressure. This is liter. Okay, so with the question carefully, this is my V1. And then my pressure is 4.0 times 10 to the power 6 atm. When the bomb casing is destroyed by the explosion, the gas is reached into the atmosphere, which reaches the pressure of 1.00 atm. So my P2 is 1.00 atm. What is the volume of the gas after explosion? That means I'm looking for V2 question mark liter, because this one has liter, given the final temperature is 260. So that's my T2. We list out everything. And then because my volume change, my pressure change, and my temperature stay constant, they're the same, stay constant. So this is a Boyle's law. I write the formula here. And I'm looking for my V2. So how can I isolate my V2? Okay, I need to divide both sides by P2. So I rewrite the formula, and then I divide both sides by P2, and then here P2 get cancelled. So finally, my V2 is P1 V1 over P2. Then I substitute all the numbers and I cancel the unit. Here, I get the calculated answer, 0.200 times 10 to the 6. This is not a good standard notation. I have to move 1 to the right-hand side. And because this is original number is less than 1, so my exponent will be negative 1. So this part will become 2.00 times 10 to the power negative 1, and then times 6. I combine the exponent and two decimal places will be 2.00 times 10 to the power 5 liter. Okay, so let me go to the back. Here is some more hint. On the back, number 5. Here it said the pressure is increased by, not increased to. So my V2 should not be 1.25. My P2 should be P1 at the P2. P2 should be P1 at 1.25 because this is increased by, not increased to. Okay, so be careful of that. And the other thing is, this one, the pressure is 8.0 atm. This one's the pressure is 1,000 torr. They do not have the same unit. So the pressure have not the same unit. I cannot cancel. So if you go back to the gas pressure conversion, the very bottom, the summary, there's a summary say 1 atm equals 760 torr. I can change my atm to torr, or I can change my torr to atm. Either way is fine. I mean, I want to make multiplication easier, so I want to cancel I want to make my multiplication. So I want the 1 on the bottom, right? I want the ATM on the bottom, 1 ATM on the bottom because I want multiplication. So I will set this up to cancel my ATM, so making my ATM to torr. You can actually change the torr to ATM, but that would be division. But actually, it doesn't really matter because you will get the same unit at the end and you will cancel. Okay, so make sure that all the unit, the pressure, volume, everything must have the same unit in order for you to cancel.